In the previous chapters, we have covered Java servlets and Java server faces. However, these components don't operate in a vacuum. Just as important as the components themselves is the context in which they operate, which is called the web context. As part of programming a servlet, you will need to define the web context by creating an object that implements the servlet context interface. If the context is defined normally, then there will be one context per web application. You can also define the context as distributed in its deployment descriptor. If this option is chosen, then there will be one context instance for each virtual machine. This allows for greater customization, but it also means that your web contexts won't be able to share global information because they won't be truly global. Each web context has four basic parts: the initialization parameters, the resources associated with it, its object-valued attributes, and its functions dealing with logging data. The implementation of the web context is designed to provide access to each of these pieces of information. Let's take a look at each of these parts and what they entail. The initialization parameters are specific values designed to be passed to certain components when the application is run. These can be things like font type, encoding style, or relevant data. The servlet context object is created when the web application is started, so it provides an easy and centralized way to access these initialization parameters. The parameters can be stored in the web.xml file for ease of use. The resources associated with the web context and its object-valued attributes have a similar function. These are attributes, data sources, or other files that are stored within the context. So why store them in the context rather than just locally with the application? Well, the web context makes its data available to all servlets, not just one, so data that will be used by multiple servlets can be stored within the web context so that they can all access it at the same time. In this sense, it is effectively a global storage space for web services. In keeping with its function as a wrapper for web applications, the web context also contains functions for monitoring the performance of applications. Depending on your implementation, it might log error messages, store and analyze user traffic data, monitor latency, and more. As with resources, it makes the most sense to store logs within the web context since it is independent of the individual applications and can easily aggregate data from all of its components. Now that we understand the basic functions of a web context, let's move on to working with the client state.